Okay, so before we get started, I'd recommend that you go to the video description and grab the GitHub link at the bottom of the description. I designed these walkthroughs as a sort of we go through it line by line, so you should probably go ahead and grab that. So this video serves as a complimentary guide to the simple Azure Containers video. In that video, what we did is we deployed these Flask microservices as containers. And so that involved three distinct steps. First, we had to deploy a Azure Container Registry. Second step is we ran a Docker build and built these services based on an Ubuntu image. Then we pushed that Docker image into the ACR repository. And then the last step, the third step, is to use the simplest Azure runtime, container runtime, which is container apps, to instantiate an instance of that container that we built. And that's pretty much what that project does. And so what we're going to do is take that build methodology, that three-step build methodology, and use GitHub Actions. So you're no longer building in your on your private box. You're building up in the GitHub environment. And so to do that, you have to do several things to set that up. So we're going to walk through that, what the things you need to do to set up. Now, you've probably heard about continuous integration and continuous deployment, CI/CD. That is a set of best practices that sort of allows us to build and deploy software in a more modern way. And all this is GitHub Actions. It's just one tool of many that allows you to implement those modern practices. So we're just going to scratch the surface of GitHub Actions, or you can do a lot of stuff. Like you can set it up to automatically build on push, and it can chain together. So we're just doing sort of a basic scratch the surface of how you do GitHub Actions to build stuff for Azure. So let's get started and walk through the steps. Now, the first thing we're going to do is we're going to create a GitHub repository from the template. All these projects that I do on this channel are template repositories, so you can clone them very easily. So we're going to walk through creating a clone of this Azure project. So I'm going to click on that. I'm going to open a new tab. And you will notice that it's a public template, and we're going to use this green button right here and say use this template, create a new repository. So I'm going to create a new repository, and I'm going to call it Azure Action Demo, and I'm going to say Demo Repository. Now ultimately we're going to put some secrets in here, and I tend, if I'm going to put any secrets into the settings, even though they're supposed to be secure, I always just make this a private repository. So I'm going to make that private. So I'm going to hit create repository. And it takes a second here. Okay, now what we need to do is, this is my clone of the repository. So I'm going to go and I'm going to pull this code into my environment. So you're going to go into here, and I'm going to choose SSH. So I'm going to end up pushing stuff back into the repository. It's just easier to do with SSH. So I'm going to copy this URL, and then I'm going to go to my development environment, and I'm going to do git clone paste. And that clones it, and then I'm going to go to the directory, and here's our project. So the first thing I'm going to do is I'm going to make sure that we have a complete build environment ready to go. Now there is a series on configuring these Terraform builds that you might want to look at, but in general most of these things you do check env, and it'll check all the environment variables that you need to be set, and then it's going to log in. In this particular case we have to have the user access administrator role, so this says we're all set in this environment. Now, what we need to do is we need to build the backend. And so I'm just going to walk through doing that, and then we'll look at the artifacts that it produces. Alright, so I'm going to go to the backend, 00 backend directory. This is sort of the bootstrap part where you have to do the remote backend. So I'm going to do terraform init. And then I'm going to do terraform apply. I'm going to hit yes, and then I'm going to let it build. Okay, that completed. And you'll see that there's three things that get generated by this build. First, we create a storage account, and then we create two backend files. So let's talk about what is a backend. Well, essentially, when you do a Terraform build, if you look at this Terraform state file, it's this giant JSON file that keeps track of the current state and compares it to what's actually deployed. And this is when you're doing a plan or apply, where you get this message that says it's going to add so many things, modify, destroy. This is what it's comparing. It's state file and whatever. This state file is in my personal development environment. So what happens when you have a bunch of people who want to work on the same general project and deployment? You need a way of having a common location to store all the state information. And so it's essentially a JSON file, just like this. And what we're going to do is we say, okay, go put this in a storage account. Instead of doing this local file as a storage account, and then multiple people can have access to it as long as they have permissions. And this allows you to build stuff in GitHub or locally, and to all be building on the same state. So that's what the storage account is for, is to storing these TF state files. And so what I'm going to do is, the other thing this thing builds is it builds in the appropriate directory, like the ACR directory, if I can get it right. It creates this backend file. So that build actually created this backend file, and the backend file has got, okay, Terraform, we're going to use Azure as a backend. Here's our storage account name. Here's the container name, and the key is here. It's just basically a directory. So that this file, Terraform, that state we were just looking at, that would exist. A file like that would exist in this directory within this storage account. And that's the same with the container app. So if I go to 03 container app, actually it's more in it. Same deal. It puts it in a slightly different directory so we can keep track of two different state files. And now when we do a build, all this is going to be put into the storage account and can be shared across projects and team members. So what I'm going to do is, I think the next step, if I'm not mistaken, is to actually push the stuff into the environment. So we did that. Okay, we've done the back end, we've gone over the back end, now we need to push everything we said back into the repository. Alright, so let's go back into here, and I'm going to do git add, git commit, add backend. Okay, so now we've pushed that remote state configuration. Now we need to figure out how to use it. So let's go back to the project within GitHub, and you'll notice at the top there's this thing called Actions. And Actions is all the pipelines. And so if you look at the original project, there was an apply.sh, that's generally about the build solution. There's a check env, that's going to be the check build environment. There's a destroy sh, and then there's a validate sh. So this roughly follows those shell scripts that we created in the original project. But what I'm going to do is, I haven't done anything, so this is not going to work. So let's see what happens. I'm going to say check build environment, and I'm going to do run workflow. Hit refresh. Check build environment. So let's watch it fail. So what it should fail on is, we haven't set those variables yet. So here we go. Set up Docker build, set up Packer, and you can see it says, hey guys, you need to set these variables. So how do you set them? Well, you go back to the project, the top, and you click on settings, and then you go to secrets, variables, and actions, and I'm going to do new repository secret, and I need to go in and put in all my values. So I don't want you to see my values, so I'm going to pause while I do that. So there's 4 values. There's client ID, client secret ID, subscription ID, and tenant ID. Okay, I have set the 4 secrets. So now what I want to do is, once I've set them, let's go back to Actions, and let's run that check environment build. Let me hit run and let it run. Click on that. Okay, so it finished running, and this should look very similar. This is the same output that is in the check env sh script. And in essence, I've taken that script and embedded it into this GitHub action. So now we're ready to do the main event. So the main event is the build all. So I'm going to go back to actions, and I'm going to click on build solution, and I'm going to say run workflow. This takes quite a bit of time because of the Cosmos DB issue. Also, just a reminder that you need to have pay-as-you-go defined for your Azure account, because there's certain services that are only available in certain regions in the absolute free account. So that's sort of a landmine to deal with. So just go ahead and make it pay-as-you-go, and you still get your credits for the initial usage. You just agree to pay if you go over it. So let's go to where these pipelines are actually stored. So if you go in your project, the way it figures out what to show in that actions thing is it looks in this directory .github workflows. And this is where we have the YAML files that define what exactly the builds are doing. And so I'm a big proponent of these new AI tools. So I'm going to show you what I do, and I get something new that I've never seen before. I'm going to go to Deep Seek, which is I use ChatGPT in the other one, and I'm going to say, let me copy that and say, give me a summary of what this action does. Alright, so we've got environment setup. Here's the jobs. Build ACR. After build ACR, there's the build Flask container, then there's the build the container app, and then there's validate solution. So let's go back to the workflow run and see what we got. Well, you get this nice little diagram that shows you exactly what's going on. It's building ACR, now it's building the Flask container, now it's going to build the container app, and then at the end it's going to validate the solution. So let's go back to the code, and really it's a lot of YAML. We set up the environment variables in each one, and when you get down to it, there's essentially a section in the YAML file where it's the shell script. And so what I do is I take the shell. I already developed these shell scripts within the project, and often that's what I do is I start off with these shell scripts that do the builds, and then when I move to an action, I'm really just grabbing those shell scripts and putting them in this run section where it's actually going to run the shell commands to do the builds. So there's a lot of similarity between the apply.sh and this build YAML as far as what code is used to build the actual solution. And so I've got one for apply.sh, that's for check env and destroy and validate. So at this point, what we're going to do is let it finish building. It usually takes about 10 minutes, and then we'll return and show the results of the build. Okay, it took about 7 minutes, and here is the build state. We're all green, so let's sort of walk through the build phases. And so the first phase is, of course, to build the container registry. So if you look at that, there's several stages. A lot of it is set up and checking out the code. So the one where we're essentially taking that shell script that we did from the apply.sh and putting it in the pipeline or the GitHub action, as you can see, it's doing the CD, and you'll see Terraform init, and then your Terraform apply. So it's just like you would see in your own shell, but it's the VM is all up in the GitHub ecosystem. Then the next thing is the build the container, and here we have to install Docker and a couple other tools. And so we are going to look at this build, and this also looks just like the shell script, where it goes through and runs the Docker on the Docker image on the Docker file, and you get a lot of output. There's probably a way to pare this down because it's not too terribly helpful. There's a lot of things in here that seem to be control codes, like reading databases. So if you go to the very bottom, you will see that it ends up pushing into the repository that we created, the Azure repository. So the second phase is complete. Now the third phase is we're going to build the container app. So again, some setup stage stuff that is common to most of the GitHub Actions in this project. Then we do a apply Terraform, and this is again looking back at build SH in the or apply.sh in the main project. You will see it's the shell script, the same shell script. And this is the one that takes forever because of the Cosmos DB part of it. So that's the third phase. The final phase, which is not really a build, it's just a validation, is we run the validate sh script, and you can see it's got this value in here. So I can click on this, and that's sort of the smoke test. It shows you, in fact, that the good to go endpoint at least is running. At this point, you could spin up Postman and test the 4 endpoints like I've done in the prior videos. I'm not going to do that here since that's not the focus of this video. So there's that. So we've covered all the sections. Now, what I'm going to do real quick is I'm going to go into my Azure console and just show you briefly what the storage account looks like and where it's storing all this stuff. So I'm going to do resource groups, and I'm going to click on a Terraform Backend. And then I've got the storage account. I click on that, and then I'll do containers, tf state, and you can see I'm storing that tf state file within the storage account. So there's only, you can continue to play with it, but there's only one thing left to do for the demo, and that's we're going to be a good stewards of our cloud accounts. So I'm going to go to Actions, and I'm going to say destroy. All right, so that is it for the Azure GitHub Actions for this project, and there'll be one more left, which is the GCP Actions.